Hello everyone. In this video lecture, we are going to discuss about the previous year questions of JEE mains based upon the topic electron displacement effect, where we use inductive effect, resonance effect, electromagnetic effect, and other effects. So let's discuss about these effects and the questions that are previously asked in this topic. So let's get started. For that, let me share my screen first. So this will be sharing of the screen. So let's start the discussion for this. Starting from the first question, arrangements arrangement of the tertiary alkyl group, secondary alkyl group, and the primary alkyl group when attached to benzene, benzyl, or the unsaturated group in increasing order of the inductive effect is. What does it states about is, let me take the pen first. It states that, let us suppose I have this tertiary alkyl group or the secondary alkyl group or the primary alkyl group when this attached to the benzene ring or the unsaturated group. The inductive order will be tertiary, secondary, or primary. It is tertiary is less, then secondary is less than primary, or it is primary is less than secondary and less than tertiary. Matlab, tertiary has the more inductive effect. Tertiary shows in the more inductive effect. Of course, higher the number of alkyl groups, higher will be the inductive effect. So option number B will be the correct answer. So option number B will be the correct answer. Yes. Coming to the next is, in the anion HCOO negative, the carbon oxygen bonds are found to be of equal length. What is the reason? It states that here the here the HC HCOO negative are found to be equal length. Why it is of equal length? Because the two resonating structures in which the negative charge is delocalized on the oxygen atom. So it will be option B. Option B. Yes. Coming to the next, the rate of the reaction in which carbonyl group is attacked by a nucleophile, and that nucleophile will attack on this carbon and a living group will be removed. So when this reaction will be faster when Z is, that means the Z should be a best living group so that incoming nucleophile can attack and this can Z can easily remove. So what is the good living group among these four? So it is chloride. Check answer. So this is chloride ion. Coming to the next. In the same reaction, when the nucleophile attack on the carbon, this X molecule I need to be removed. Again, the X must be a good living group. Among this, the good living group is again chlorine. So this is all correct. Let me check the previous one first. So chlorine, I need to check is correct answer. Coming to the next is presence of nitro group in the benzene ring activates the ring, deactivate the ring, and what effect others. So NO2 group this NO2 group is NO2 group is matter directing deactivating group. So it deactivates the ring. First point. And secondly, benzene do not undergo nucleophilic substitution. Benzene always undergo electrophilic substitution. So deactivating group with electrophilic substitution, activating electrophilic, no. Random basic, no. Deactivating to nucleophilic, no. Benzene do not give nucleophilic substitution. Benzene gives electrophilic substitution, and nitro gives a deactivating group. So option D will be the correct answer. Let me check. Option D. Yes. Coming to the next, which of the following shows the highest dipole moment? So the highest dipole moment, among these four will be shown by which of these? So let me take the pen first. So this pen, so what happened over here is this carbon is sp2 hybridized. This is again sp2 hybridized. This is again sp2 hybridized. So all the three carbons are sp2 hybridized. So electron density, being oxygen is present here, is moving towards this side. So net dipole moments toward this side. So let me write the net dipole moment will be on the oxygen side. Here, this carbon is sp2, this carbon is sp2, this carbon is sp3, this carbon is again sp2. So this is sp2, 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 and sp3. Since this is sp2 and sp2, so some of the electron density is moving upward because of the oxygen. Here, because of the oxygen, it is moving in this direction. And of course, this sp3 and this is sp2, this is again this. But at this point, the electron density is moving toward this side because higher the S character, higher the electronegativity. So sp3 has 25% S character and sp2 has 33.3%. So this has greater electronegativity. sp2 hybridized carbon has a greater electronegativity. So overall net is moving upward, but there is some cancellation because of this arrow. So this is not as strong as the previous one. Likewise, this carbon is sp3, this carbon is sp2, sp2, sp3, and sp2. Since these are sp3 hybridized carbon atom, so electron density will be moving toward this side or this side, but there is a cancellation point. Electron density is moving towards this side or this side. Again, there are certain cancellation points. So net is moving this, but there are certain cancel points, so one has more dipole moment still. Again, here the dipole moment is shifting toward this side, and the dipole moment shifting toward this side as well. The dipole moment is still zero because of symmetrical electronegativity difference among the two directions. So option 1 will be the correct answer. So let's discuss about the option 1 first. So it will be option 1. So check answer. This is all correct. Coming to the next, let me pick my screen first. On treating the following compounds with a strong acid, the most susceptible side for the bond cleavage. सबसे ज़्यादा bond cleavage के chances, where will be the bond cleavage chances will be higher. So it will be on 1 and 2, no, because oxygen and there is delocalization, so it is not possible. Here also oxygen 2 and 3, it's not possible. So most important cleavage is oxygen sp2 hybridized, oxygen sp2 hybridized, oxygen sp3 hybridized. So this cleavage 5 and 6 is better cleavage. So let me check the options, whether the options are there or not. So option 5 and 6 is a good. So good. Coming to the next is, in the following figure compound, favorable protonation sites are. So favorable protonation sites will be the sites that where the lone pairs are not involved in resonance. Since this lone pair is involved in resonance with this conjugation, this is also lone pair, single bond and double bond. This is also in conjugation. But this carbon, this nitrogen lone pair is not involved in the conjugation because the pi bond, sigma bond, pi bond is there. Again, pi bond, sigma bond, pi bond is there. Pi bond, sigma bond, pi bond is there. So B, C, and D lone pairs, B, C, and D nitrogen lone pairs are not involved in resonance, so they can easily protonated. So option B, C, D, that means option A, which include B, C, D nitrogens, is the correct answer. Coming towards the next, the increasing order of reactivity of the following compounds towards aromatic electrophilic substitution is. So, this aromatic electrophilic substitution, electrophile, incoming electrophile will come to those benzene rings or the substituted benzene rings where the electron density is higher. I need to just check where the electron density is higher. OMe is showing plus I and plus R effect. So it is showing maximum electron substitution. Then followed by Me group. Then this deactivating group at orthopara activating. Orthopara deactivating group chlorine is the third, and Cn, since it is minus R minus I group, so it will be at the fourth position. So option B having the higher priority than C, A, and D. Any option with B higher priority and D lesser priority is this. It's BCAD, BACD. It's a good answer. Among this, the increasing order of the reactivity of the following compounds towards electrophilic aromatic substitution. Again, electrophilic substitution reaction where the benzene substitution by substitution in the benzene, electron density increases. This will be the higher priority. That will be the higher priority. Among this methyl group is showing plus I effect. So electron density increases. So second will having the more priority. As compared to this showing the minus I group, and it has minus I plus R group. So the second priority, and this is minus R minus I group, it's having the third priority. So second, first, and third will be the correct answer. So it's second is having the more priority than first and then third. This is correct. Coming to the next is, which of the following having the shortest CCl bond? Shortest CCl bond will be that bond in which minus I groups or the resonance or the double bond character develop between the carbon and the chlorine. So this benzene, this structure, chlorine is showing the resonance, but not as much. Chlorine is again showing the resonance, but O group is also showing it's backward. Chlorine is showing the resonance, fine. Chlorine is all the three are showing the resonance, but here the chlorine is showing the resonance and the nitrogen is itself getting the electron. As a result, carbon chlorine bond is getting the partial double bond character in a more way. So option B will be the correct answer due to minus I group. Here plus I group, here plus I group. There is no group, there is minus I group. So minus I group will be the correct answer where CCl bond is the shortest bond due to partial double bond character. Increasing order of the boiling point. Boiling point is based upon the hydrogen bonding. Where the hydrogen bonding is higher, the boiling point will be higher. Among these four, above group is OH, 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 OH. This is nitro, this is amine, this is methoxy, and this is methyl. So nitro is showing the greater extent of hydrogen bonding. Then amine is showing the hydrogen bonding. Here the hydrogen bonding is not shown by this group, but shown by this group at a smaller extent. So it is second, then third, then fourth, and then first. Do we have second, third, fourth, and first? Let me check the answer first. Second having the more. So this is correct. Do not exhibit the resonance. For the resonance, here is on oxygen, there is lone pair and double bond. Do not shows the resonance. Again, this will shows the resonance. Benzene. This is oxygen lone pair, then sigma bond, then double bond, showing the resonance. Here also CONH2 group will show the resonance. And this group is not conjugated. It is double bond, then carbon, then single bond, then single bond, then nitrogen with the lone pair. So two single bond, two sigma bonds are in between the pi bond and the lone pair. So this will not show resonance. So this will be the correct answer. Which one among the following resonance structure is not correct? Out of these four, one is not correct, and the nitrogen which carrying positive charge and the adjacent carbon is carrying the positive charge. It is not possible during the resonance. Positive negative is possible, positive negative is possible, and positive negative is possible. But the first, where the positive positive is occurring, it is not possible at all. So this is correct. Coming to the statements, hyperconjugation is a permanent effect. Yes, it is correct. Statement 2, hyperconjugation in ethyl cation involves overlapping of carbon with sp2 hybridized and the hydrogen with 1s bond with the empty 2p orbital of the other carbon. This is not correct because this carbon where the overlapping of CH bond occurs is sp2 hybridized, not it is sp3 hybridized, not sp2. So here it is sp2. The statement 2 is wrong. Only the first statement, which shows hyperconjugation is a permanent defect, is a correct statement. So first is correct, but the second statement is false. So option C will be the correct. Check answer will be correct answer. So in total, we have 36 questions, and at this point we are on the 16th question. The compound which shows significant intermolecular hydrogen bonding. So this shows intramolecular hydrogen bonding. This shows intermolecular hydrogen bonding. This do not show hydrogen bonding because of the steric hindrance factor. So only B will shows the hydrogen bonding. So B will be the correct answer. Yes, it is absolutely correct. Coming to the next, arrange the following in increasing order of the reactivity for nitrogen. Paraxylene means benzene group, benzene ring containing CH3 groups, two CH3 groups at para position, 1 and 4 position. Bromobenzene, it's a deactivating group. Mesitylene, three CH3 groups at the first position, third, and the fifth position. Nitro group, and then the benzene ring. Fine. So here it shows so many uh, rings. So paraxylene, so it shows what it shows. Mesitylene is having three CH3 groups. So reactivity increases for nitration. Paraxylene having two CH3 groups. So this is also nitration easily. Nitration is easily. So C is having the greatest nitration, and then followed by A, then the benzene ring, then it's a deactivating group bromine, and then nitro. So it will be C, A, E, B, D. Any option for this? It could be C, A, E, B, D. C, A, E, B, D. Let me check the answer. This will be the correct answer. Let's discuss the structures. This is mesitylene, paraxylene, benzene, bromo, benzene, and nitrobenzene. These three are orthoparadirecting and activating groups. Orthoparadirecting and activating groups, number wise 3, number wise 2. So it is having more easily nitration than this. Then benzene. This is orthopara but deactivating group. All the halogens are deactivating groups. And then metadirecting group but deactivating groups. Metadirecting are always deactivating groups. Resonance in the carbonate ion is all the three. Which of the following is true? It is possible to identify each structure individually by some physical chemical method? Not at all. All these structures are dynamically equilibrium? Not at all. All these are imaginary structure. Each structure exists in equal amount? Not at all. Imaginary structure. Here, CH3 having the single structure resonance hybrid. Yes, CH3 actually it is having the single resonance structure, that is resonance hybrid. This is a correct. Coming to the next question. Given below are two statements. One is labeled as assertion and the second is labeled as reason. Benzene is more stable than hypothetically cyclohexatriene. Yes, benzene is more stable. Why it is more stable? Because delocalized pi electron cloud is attached more strongly by the nucleus of the carbon. That is also correct. So assertion is correct and reason is the correct explanation. Benzene is stable because of the delocalization of pi electrons. Both are correct. So A and reason are correct and reason is the correct explanation of assertion. So B option will be the correct answer. Coming toward the 20th question, which will undergo deprotonation, it will easily remove H positive in the basic medium. So this H is more acidic because of minus I groups, presenting two minus I groups here. This is less acidic because the plus I groups OMe are present here. This is again less acidic because of the OMe group, at least one OMe, but there is no OMe group. So which will do most readily? So A will undergo most readily deprotonation. So let me check the A option. That is correct. Coming to the 21st question, a set of matter directing functional groups of the following sets. This is matter directing CN group, NH2 is ortho para directing. Wrong हो गया. CN matter directing, CHO matter directing, NC is again ortho para directing. Wrong. Nitro, meta, amine, ortho para. Wrong. Nitro, meta. Aldehyde, meta. Sulfonic acid, meta. COR, RCOR, ketone, meta. So all these four are meta. Yes. Functional group showing negative resonance. Minus R is shown by the COOH group, carboxylic acid group. Coming towards the next, ionic reaction with organic compounds proceeding through homolytic cleavage. No, ionic reactions involve cation and anion formation. So cation and anion formations are always conducted by heterolytic bond cleavage. So B is correct. But there is free radical, free radical, free radical. No free radical is occurring by heterolytic cleavage. Heterolytic cleavage involves ions. So only B option will be correct. Only B options will be correct. That is correct. Coming to the 24th question. Which of the following compounds will most easily be attacked by the electrophile? Any electrophile will be attacked because of the plus I resonance, plus R group. It is showing plus R, but it is a deactivating group. It is showing plus R and is activating group. It can be an answer. No group, and it is showing minus I, but do not show any resonance, so it will not. So B option, phenol, let me check, will be the correct answer. Coming towards the total number of deactivating groups, that means I need to calculate matter directing group. So this carbon is sp3 hybridized and this carbon is sp2 hybridized and followed by oxygen. Yes, it is a matter directing group. Nitrogen is followed by carbon. No, not matter directing, orthopara. This is again orthopara. This is matter directing carbon followed by more electronegative nitrogen. So one this and a one this. So two are there. Among the following total number of matter directing groups on the basis of integers based. So it is orthopara, it is meta 1, it is meta 2, orthopara, it is again orthopara, meta 3, orthopara, meta 4. So chlorine orthopara. So 4 is the correct answer. Electrophilic substitution we need to arrange. Firstly, due to plus R, B, then none, A, plus R. This is plus I plus R, but deactivating group C. So B, A, C, and then D. B is having more priority, A, C, and then D. So this will be the correct answer. Interaction between pi bond and the lone pair of electron present on the adjacent atom is responsible for resonance effect. It's statement based question, resonance effect. Correct stability order. Here there is no charge separation, though this is more stable. Charge, oxygen is getting my negative charge and the carbon is getting positive charge. Oxygen is getting positive and the carbon is getting negative charge. So first option is least stable because oxygen itself is carrying the positive charge. So third, second, and first will be the priority order. Third will getting the more stability because there is no charge separation. Then second, oxygen is carrying the negative charge. Then first. Coming towards the next question. How many compounds among the following compounds will show inductive, mesomeric, and hyperconjugation? Firstly, let me discuss about mesomeric. Yes, it is showing mesomeric. Inductive effect, yet yes, it is showing inductive effect OCH3 group. Hyperconjugation. For hyperconjugation, I want double bond followed by alpha hydrogen. So it is not having the alpha hydrogen, which is sp2, sp3 hybridized. So this is not so. This double bond is having sp3 hybridized carbon containing one alpha hydrogen. So one option, note, not showing hyperconjugation, not showing resonance. This this double bond is having a carbon which is sp3 hybridized and carrying alpha hydrogen. Second option, this is third, and this again is fourth. So it will be from my side, it is one, this is two, this is three, and this is fourth. So four options are there, which shows all the three effects: inductive, mesomeric, and hyperconjugation. Correct answer. Coming toward the next, NH2 is showing plus R effect. Fourth one. This is electron will be moved towards the reagent. It is showing plus E effect. So B is having the 3. So it is 4, 3, then 1, 2. 4, 3, 1, 2. It's 4, 3, 1, 2. Correct option. Coming toward the next. Among the incorrect statement, electromagnetic effect is a temporary effect is correct. Uh, Hydrogen ion shows negative electromagnetic. No, hydrogen ion shows positive electromagnetic. This is the wrong statement. Hydrogen ion shows positive electromagnetic effect. Here it shows negative. So wrong. 33rd question. The correct arrangement of decreasing order of electrophilic substance. Again, uh, this is having plus R plus I effect, so showing greater stability. So third is having most electrophilic substitution, then first, then second, fourth. Third, first, second, fourth. Third, first, second, fourth. Nitration on meta-xylene. Xylene which carrying CH2 CH3 groups at the meta position and 1,3 position. With nitric acid and sulfuric acid on oxidation give 4-nitrobenzene 1,3 dicarboxylic acid. Yes, nitration is occur in the fourth position and CH3 group is turning into COOH group because of the sulfuric acid. This is the correct statement. CH3 is orthopara directing and NO2 is meta directing. Both are correct statement. So correct. Coming towards the last second question. Total number of nucleophiles. Nucleophiles are those which have lone pair or extra electrons. 1. Sulfur is having an extra electron. It's 2. Sulfur is having extra electron. 3. Double bond. Pi bond is also loosely held electrons, so easy to donate. Nucleophile. 4. OH with lone pair again 5, plus sign no, CO group no, CN group no. So it's 5. Total it's 5, which shows nucleophilic number of nucleophiles is 5 here. And the last question is identify correct statement for this. These groups are activating group. So yes, these groups are activating groups. CN and OH are meta directing. No, OH is a orthopara activating group. It's not meta directing. So B is wrong. CN and SO3H is a meta directing group. Yes, correct. Activating group act as a ortho or para directing groups. Yes, it is also correct. So it's A, C, D are correct. Halides are activating. No, halides are deactivating group. So A, C, and D. A, C, and D is the first option is the correct. So in this video, we have discussed about 36 previous year questions based upon electron displacement effect. Try to practice one by one. All these questions are from JEE mains. It's from 25, it's from 23, it's from 24, it's again from 24 and so on. So see you in the next video. So in this video, we have discussed about electron displacement effect, that is all based upon inductive effect, resonance effect, hyperconjugation effect, and the fourth one effect is electromagnetic effect. So see you in the next video. Till then, keep practicing. Thank you for watching.